So here we are going to discuss about three division operators that would come under arithmetic operators in Python. So we have division operator, floor division operator, modulo division operator. We're going to see what these three different operators are, how are they different, and also we're going to go through two different examples that would help us understand these operators in detail. So starting off with the division operator we have, this is the normal division operator by using a backslash. So for example, if you divide 10 by 3, so 10 divided by 3. So your 3 times 3 would be 9 and you'll get the remainder as 1, and it keeps going on when you use a backslash. As long as you get the remainder as 0, the interpreter would continue performing this division operation, and it would return the quotient value as the output. So here it would be 3.33333 and 5. So that's what a normal division operator would do. The next one we have is floor division operator. Floor division operator is represented by using double backslash, and that's how the interpreter is going to identify it. And what this floor division operator is going to do is, this is also going to return the this is also going to return the quotient value. For example, if I divide 10 by 3, the same example, so 3 times 3 would be 9. And the remainder would be 1. So it keeps going again. 3 times 3 would be 10. The remainder would be, the 3 times 3 is 9. The remainder would be 1 and keeps going. So this would be your quotient value. But when you use a floor division operator, the interpreter only would return the integer part of the quotient value. It would neglect the decimal part in the quotient. So the output would be 3. So your answer is gonna be 3, which is just the quotient part of the integer operator. We also have something called floor division operator. Floor division operator is represented by using a percentage operator. So what would happen is, again with the same example, 10 divided by 3. So 3 times 3 would be 9 and the remainder would be 1. If you can't perform further division without using a decimal part, the interpreter would stop dividing it there. And this remainder value would be returned when you are using a modulo division operator. So modulo division is going to return the remainder. Your floor division is going to return the return the quotient, but only the integer part, neglecting the decimal. And the final division operator would just return the quotient value completely, the actual quotient value. So these are the three different division operators we have in Python: division, floor division, and modulo division. Now let me take you through two main examples that would help you understand these two operators in detail, especially your floor division and the modulo division operator. So here the first example is about figuring out how many digits are there in a number. So I'm going to take a variable called a, and I have a number called 123. So the number of digits here is 3. Right, so this is what I'm gonna do. I'm gonna count how many digits are there in a number and gonna return that. So for that we are gonna use loop here, and the loop that I'm gonna use is while loop. And I need a variable called count. The reason is, this is gonna keep a count of how many times in the loop is repeating. That would in turn tell you how many number or how many digits are there in the number. So I'm going to start off with 0. Initially, I have not counted any number. So I'm going to begin with 0. And my loop condition. So this is a while loop. You have to write the keyword while and write your condition next to while. The condition is, as long as the variable a is greater than 0, the loop is going to keep repeating. So you have to end it with an colon, and whatever lines of code that you think should keep repeating inside the loop has to be indented properly within the loop, having a proper space in the beginning. So as soon as I enter inside the loop, I'm gonna count gonna increase the value of count by 1, because I'm gonna count for the first time now. right? Because my variable value is greater than 0, which means it has a number in it. So I'll have to increase the count right away. And then I'm going to perform a floor division operator here. The reason is, see, I'm going to take out one digit. I'm going to count one by one. All right. So I'm going to first of all come from the end. So 1, 2, and 3. We have 123. If I divide 123, because I've counted already, I've taken account of the first digit, which is nothing but the unit digit here. Now I'll have to remove the 3. And how could you do that? Is by using a floor division operator. So when you divide 123 by 10 by using a floor division operator, what would happen is, so here it is, you have 123 dividing it by 10. And the quotient, so the quotient value would be 12. So 12 times 10 would be 120 and the remainder would be 3. So 12.3. So this would be your answer when you divide 123 by 10. Now, since I'm using a floor division operator, the interpreter is going to only return the integer part of the quotient, which is 12, neglecting 3. This is how you could get rid of the unit digit by dividing it by 10 using floor division operator. So here, my output would be, my div value would be 12 because I'm storing this division answer inside the variable called div and assigning the div to the variable a. So now the variable a is gonna carry 12, which is greater than 0. So still, which means still I have digits left in it. So my count is again gonna increase by 1. This time it's gonna become 2. And then now I'm dividing 12 by 10. So here you go. So 12 divided by 10. So 10 times 1 would be 10 and the remainder is 2. And then 1.2 would return you the remainder as 0 here. So now the interpreter is gonna just pick the integer part of the quotient. So this time your div is gonna store 1 inside it. And then the variable a gonna carry 1, assigning div to a. Now again gonna check whether a is greater than 0. It is greater than 0. So this count is gonna be increased by 1 again, which should become 3 this time. And then div would be 1 divided by 3. Sorry, 1 divided by 10. So when I divide 1 by 10, so when I divide 1 by 10, so it would obviously start with the 0 value decimal so that I could add another 0 in here. So 0.1. Remainder would be 0. Now it is going to carry the integer part of this quotient. That would be 0 here. So the div would be 0. And a would in turn become 0. Now your condition is going to become false here because a is not greater than 0 because a is same as that of 0 here. So it's going to return false. So the interpreter is going to exit from the loop and print the total number of digits. So the final count that we had is 3. So that's what would get printed here. So there you go. This is how you could count number of digits in a number. Excuse me. So by making use of the modulo floor division operator. The next example that we have is what is the sum of the digits in a number. For example, if my number is 123, the sum would be 6, right? 1 plus 2 plus 3. This is what my program is gonna find it out. So I'm gonna create a variable called sum, which is gonna carry the sum of the digits. So assigning 0 to it initially. And since I'm going to keep repeating this, right, I'm going to take out, what I'm going to do is I'm going to take the units digit, which is 3, and store it under sum. And then take 2, which would become, after storing 3, I'm going to neglect 3. So I'm going to take 2, which would become the unit digit for the second time, and then going to store 2 inside the sum. and then gonna remove 2, take out 1 and store it inside sum. So as long as I have numbers, or as long as my a variable is greater than 0, I'm gonna keep repeating this action to each and every digit in the number. So my condition would be while a is greater than 0, and here I'm gonna get the help from the modulo division operator. So gonna store it under rem, a variable. So rem equals to a divided by 10. So how would this work is, so when I divide, divide 123 by 10, so this would be, okay, this would be 12 times 10, that would be 120, and the remainder would be 3. This is where the interpreter is going to stop dividing when I use modulo division operator, because I cannot divide 3 by 10 further without using the decimal number. So it's going to stop it here. Now your rem is going to carry 3 here. The value the rem is going to carry initially is 3, and I'm going to add 3 to this sum. So that would become 0 plus 3, because sum is initially 0. So now sum is carrying 3, and then div would be, why div is because now after adding 3, I don't want 3, I have to neglect this 3. So what I'm going to do is, again, I'm going to perform 123. But I'm going to I'm going to divide 123 by 10 by using floor division operator. So 12.3, and this is the output I would get, and it's gonna store the integer part of the quotient inside the variable called div. So here it's gonna store 12 and assigning that to the variable a. So now your a is still greater than 0. So I'm gonna continue performing the same action. So this time I'm gonna divide 12 by 10. So how would that be is, so 12 divided by 10, 10 times 1 would be 10 times 1 would be 10, and the remainder would be 2. So this time my rem is gonna contain, the variable is gonna contain 2, and I'm gonna add, already my sum is carrying 3 now. So I'm gonna add 2 to it. So 3 plus 2 would be 5. Okay, so now my sum value is 5, and my div is gonna perform the calculation, division again in order to neglect this 2. So that would become 1. So how it's gonna become 1 is, I'm gonna continue with this. When I divide 12 by 10 by using floor division operator, this is how it would become. Floor division and normal division would, when you use floor division and normal division, your interpreter would continue dividing until you get the remainder as 0. So now this 1 would get stored inside this div, and the a is gonna, I'm assigning that div to a. So now 1 is getting stored inside the variable a, and still 1 is greater than 0. The condition is true. So interpreter is gonna perform the action again. So this time I'm gonna divide 1 by 10. So when I divide 1 by 10, 1 is divided by 10. When you divide 1 by 10, the remainder would be 1, because I cannot perform any calculation. So we are going to consider this digit as it is. If you divide a single digit by 10, when you use a modulo division operator, the remainder would be the single digit. So it would be 1, and adding 1 to the 5, which is the previous value I had, which would become 6 this time, and then dividing 1 by 10 by using floor division in order to neglect 1 and see if there are any other digits in it. So if I do that, it would become 0.1. I would get the remainder as 0, and the integer part would become 0. So now div is going to contain 0, and my a variable is also going to contain 0, and performing the condition check again. This time 0 is not greater than 0, so the condition is false. This is where the interpreter is going to exit from the loop and print this statement. So the sum of the digits in a number is going to print this statement along with the variable sum. That would become 6 here. So let me run this. You can see it, or I could change the number to 453, which would be 12. 4 plus 5 plus 3 would be 12. So there you go. So the same action is happening. The same concept is being used in order to find the number of digits or sum of the digits in a number. So I hope with these two examples, the flow division and modulo division operator are pretty clear here. We'll see you with a different concept in the next video.